Hello everybody, I just wanted to give you an update on my throttle progress. I've gotten about 90% done. There's two things that are still kind of problematic. The first one's the parking brake. I had to completely disassemble my parking brake lever. I was using a actuator from a car door, and I kind of broke it, but I think it was a good thing because I wasn't very happy with how it was working. Every time I would pull up on the parking brake lever, it would either pull down and you had to pull up just a certain way to keep it up, and so it was just kind of more of a hassle than it was worth. So I'm going to redo that, and I'm going to try to do something that I know nothing about that I saw Fred do on his, which is a magnetic catch. So those parts should be coming in this week, and I'll try to get that all figured out. And then as well, I had to, I don't know if you can see down here the servo for the spoiler speed brake. So I went with the Futaba servo. I originally was trying a high-tech HS815 sail servo, and it, for some reason, every time I tried to power it through the board, it would die, and I'd actually have to reset the board entirely and reload the SIAC software. So I've gone ahead and went with this servo for now. I'm not happy with it. It's not very fast. It does work, it's got enough torque to handle it, but it's not very quick, and I'm going to do some demonstrations so you can kind of see what's going on there. And then besides those two things, everything else is working mostly how I want it. I still have one issue that I think is more of a software thing that I need to fix, and that's the lever 2. Whenever it's in the auto throttle mode, it has a tendency to hunt, whereas the lever 1 seems to work just perfectly, and probably show you what's going on there. But it's good enough for me right now. I'm sure once I get some more time to play with the SIAC code, I will, but got a lot more other things I need to finish, so I'm happy with it for at the moment. It's just an eye thing, and in fact I noticed while I was flying it, I don't even really notice it. I can't hear the throttles moving. I can't even notice the actual I can't notice it. Well, and I was flying at night too, so that might have helped. But anyway, kind of give you a rundown of what I've done so far. So, just kind of like Fred's setup, I've got my two motors, DC motors, that you would typically see in robotics, as well as my string pots. And you notice that my string pots, one of them, well, they're both not configured exactly the same. And so there's a slightly different variation in the potentiometer value, but in SIAC you can actually normalize those back to 0, so they both will go from 0 to 255 pretty much uniformly once you set up where the top of the end of the potentiometer is and the bottom end of the potentiometer in the SOC script. It'll normalize those values for you, so that's not a big issue. And the reason I had to do that was for I guess I won't get into too much of it, but when I had this string pot positioned back here, and you can see the holes, and I had it positioned exactly like this guy, what happened was there was too much sideways, probably a 45-degree angle on the string coming out, and I didn't like that. I didn't want to put too much tension coming out, and I don't want to start rubbing on that string cable, even though it's kind of it feels like a Teflon coating, so I think it'll handle it just fine, but I wanted to make sure it was coming straight out, or out as much as it could straight. So I went ahead and did that, and it seems to work just fine. It just looks a little funny, but once I put the pedestal on it, you won't really notice it. And then, yeah, so we've got our DC motors. Here's our clutches, and you can see, oh, maybe you can see right here, these this is a little thumb. You can basically adjust this and tighten. I don't know if this camera is going to see very good close up, but there's some little springs in here. Yeah, it's probably hard to see, but some little springs in here that'll tighten up, and it'll put tension on this clutch plate, and that's what allows you to adjust the tension of those motors. And as well, that's what allows you to adjust the tension from the manual input. So those are the main levers. And then what you can see I've done here too is I've gone ahead and wired, since I know there's a probably good possibility at some point in the future I'm going to have to be disconnecting the board, I didn't want to have to disconnect 500 wires and then have to reconnect it, because my plan is, you can see here's my DC motor board. My plan is, once I get the pedestal built, which is the next step, and I'm going to put this board in there with all the radios and other components. So that's the plan. So for now, I figured it's probably easier just to wire up. I use DB25 connectors, and I use 2 different sets. The first set, I put all 3 motors on it. These 2 lever motors and then the trim motor. I've put them on these DB25 connectors. And I don't know if you can see in here too, but I wasn't sure how well those 1 pin would handle the voltage and the amperage. So I went ahead and soldered 2 pins together. See if I can get this in focus. I don't know if you can see that, but I went ahead and bridged 2 pins at once. So each lead from the motor gets 2 pins from this connector. So that should help in any kind of voltage, and so far I haven't seen any issues. And this is a 16 gauge wire. So one thing I wanted to do, because I noticed before I was building this and helping or reading through the forums that you guys had all mentioned some problems with interference and the board shutting out. So I went ahead and went with a little bit thicker gauge wire, even though it's probably not necessary. But it's 16 gauge wire, and it's pretty thick shielding, and the goal was to help eliminate any kind of electromagnetic interference and stop the board from shutting off, and so far it's been pretty successful. And then as you can see here, I've also twisted the wires, all the motor cables. I've twisted them the whole way, all the way up pretty much until they're soldered on here, and that also helps to cancel out any electromagnetic interference. At least that's the theory that I'm told. So I've gone ahead and I did the same thing with the pots. I tried to twist these a little bit, and then again thicker wires to help eliminate any voltage variations coming from the other wires. So that's for the motor voltage, or for the motor power. And then here you can see there's another DB25 connector, which had just enough pins. I think I might have 1 or 2 spares. And what this gives me is it gives me all the switch outputs. I think I've got 8 switches total, and then the rest are for the other pots, for the flaps and the servos, as well as the servos, or no, I'm sorry, not the servos. Some power as well, because I got 12 volt and 5 volt feeding into this for the parking brake light, and also for, I don't remember. But anyway, I've wired everything else that I needed to coming out into this 125. So, if in theory, or not in theory, it does work. If I ever have to disassemble this or take it out for whatever reason, I can just pop those 2 cables, undo it, and I've got everything I need without having to fiddle with undoing all these wires. So you can see in the board here, and it makes it much cleaner, I think, too. So it's just a little, basically a tail coming out of this board. Oh, I need to plug that back in before we start the show too. Let's plug this back in. So we got power. Okay. It's a bit of a mess in here. I'll try to show you what's going on, if you can see it, I hope. My cable management skills are not pretty. I tried to do a good job, and I did some of a good job, but there's a little bit of a bundle of mess right here, which is kind of ugly. But I didn't want to cut off any of the original cabling, because I may want to use it later, so I went ahead and left all the old original cables. I still have them stripped off here. I just tucked away, out of the way, so it doesn't look pretty. And if I were to cut these cables off, it would be fine. But anyway, that's I'll keep moving up there. So, and then here you can see, so the bottom servo is for the trim indicator, and you can see this linkage rod that goes up to, if you can see in here, this right here is the trim indicator lever. So I just drilled a hole in there and put a nut and bolt through that, if you can see it. But this rod comes all the way down to this servo here, and that powers the trim indicator. And then this is the spoiler servo, which is not ideal at the moment. I bought another high-tech servo. I'm going to see if I can figure out another way to make that thing work, either with some capacitors or a different supply. I've also bought a different tester for the servo, so I can test this outside of the OpenCockpit board and not worry about frying it or anything like that, and make sure the servo's okay. It may have been I had two bad servos, which seems very unlikely, but it could be a possibility as well. So I got another way to test the servo without using the OpenCockpit board, and hopefully that works, because I know that's got a lot more torque and it's a much faster action. So hopefully I can use that. If not, this is just going to have to work, because I can't find any other servos that are analog that'll take the torque. So if you have any suggestions, I'd love to hear those as well. And then tucked back here is the servo trim motor, which was a fun process in itself. If we come around to the side here, get a little bit of a better angle. So I had a hell of a time trying to find, one, the sprocket size that would match, and two, the chain that would match the sprocket from the original, because I know some people actually get the original chain from the unit when they get it, but mine wasn't. I didn't come and have any chain, so I had to find the chain. I found some online that had the forum and posted. I think this is a number 35 chain, and then I had to find a sprocket which would fit, and it's kind of hard to tell. It's really hard to tell unless I were to take this apart and show you, but basically this sprocket hub for the drive shaft is on another hub assembly, because this is a half-inch opening right here in the hub, and I need to go down to like an eighth of an inch to get to the connect to the actual motor. So this sprocket hub connects to another hub, which then finally attaches to the motor itself. I didn't think it would work, but it did, luckily, because there's only maybe about the width of this cable here that comes out from the half-inch to the eighth inch. Or maybe this is I don't know. But there was literally just about that much for this sprocket. It uses set screws. This sprocket uses set screws to attach this hub assembly, which then attaches to the motor. So there's a two-piece. This is one piece, and then this little silver thing that you can kind of see looks like a square. That's another piece, and that little piece only has about that thickness from this wire sticking out for this sprocket to attach to. So I clamped it in there. It was a really tight fit. I clamped as much as I could, pressing them together this way, and then I used the set screws, even though I wasn't sure they would actually catch on the metal, because there wasn't enough to catch on. But so far it's working out great. I just think I may have just got lucky, but yeah, sorry if my explanations aren't very good. I'm a good explainer and drawer on a board, not necessarily by speech. Anyway, and then we got here, and this is our 5-volt backlight cable. So we just did a little fancy thing there, but that comes out, and again, once I get all this is more of a temporary thing, but eventually this will get hidden in the pedestal, and I'm probably going to build a wooden base underneath this whole thing to support the pedestal and the throttle, so that I can put this thing on wheels, because it does come out pretty far with all this extra stuff, and the room that I'm in is not very long, so I want to basically be able to turn it sideways easily. So I'll put a base underneath it so I can put some wheels on it and spin it around the room, and not have it take up the whole space. Okay, so I think that's good enough on what I've got going. I'll try to create another video that goes into more detail, or a little more clear on the inner workings there once I take this thing apart and build the pedestal, so that I can give you more light and walk around it more. But amazingly, what I wanted to show you today is how this thing works so far. So the first thing I'm going to do, we've got our MIP here, our MCP. Yeah, I know I don't have a glare shield. And then we've got our overhead unit here. So that's what we got in the cockpit so far, and as well a force feedback yoke from Flight Illusions, which works out very nicely, except their software sucks. And I will I've already built some custom software which I had to reverse engineer how they talk to this thing, the serial port, but I was able to spend many hours reverse engineering their bits, and I've got some software that I'll be releasing once I get that piece finished. Again, that's probably going to be farther down the line. I want to get more stuff in the cockpit working before I mess around with tuning this, but I'll open source that so that you guys can add to it, and I think it's more realistic, and I added some more features which are better for ProSim as well, because they don't support a lot of things. So anyway, that's kind of a tangent. So let's go ahead and show you more or less what I'm going to do first. Is I'm going to do a rejected takeoff. So we'll set rejected takeoff on auto brake. What happens is I'll go ahead and we'll go ahead and press the toga button. You can now see the throttle's going. Oh yeah, one thing I should have set a long time ago too was the flaps. So we got flaps coming down to 5. You can see here flaps going over to 5. So once we get to 65 knots, we'll disconnect the auto throttle, hit the reverse thrust, and you'll see the speed brake. Okay, do that, reverse thrust, and the speed brake activates, and reverse thrust off, speed brake down, and that's, I think, what you would expect in a real plane. So that's part 1. So now what we'll do is I'll demonstrate, I'll show you real quick. So I'm going to use the trim wheels here. You'll see there's the trim motor going. You can see the indicator. Go backwards. So you can see it's a little noisy. So one thing I've done is I've taken these 2 switches, the right switch, I turn that off. Now when I move the trim wheel, you'll see the trim indicator continues to move, but the motor's not going for this trim wheel. So that keeps it from, you know, if at night or whatever you got kids up or going to bed, you could still use this thing without the trim wheel going, and it just keeps it from being kind of annoying and loud. So we'll turn that back on. We'll see. There we go again. Okay. And then just real quick too, I've chosen this switch to be my backlight on or off switch, and see if, I don't know if it's going to show up very well in this video. You probably can't see it. Alright, maybe you can. So I don't know if you notice it goes from white to kind of a orangish reddish, but there is a backlight here, which goes off, on, off. So that switch manages the backlight power. Okay, so now what we'll do, we will reset the auto throttle, and we'll go ahead and try this again. We'll take off again, and you can see there the maybe not, didn't catch it this time. I'll turn the brakes off. So we'll now go ahead, and then what I'll do is I'll take us off, put the autopilot on, and I'll go through some motions on, you know, changing altitude and all that stuff. So you can see kind of the throttle's going forward and backwards. You can see the trim wheels going and everything else like that. So we're still getting a takeoff speed here. We get to about 138 and 140 knots. And we start pulling back. And here's my sim over here, just temporary. Eventually I'm going to get an actual projector. So gear up. Go ahead and trim this thing down. Okay, we're going to head and turn the autopilot on. So now here you can kind of see the motions. The auto throttle's on now. flaps up. You can see the throttle coming back. You notice that right throttle kind of hunts a little bit. I think it's more of a speed issue with a lever 2. And you can see that right when hunting. It eventually catches up, and it's pretty dang near right on the side there. Once they eventually do catch up, there's just a bit of a lag, which is okay with me right now. Eventually I'd like to see that perfect. But I don't know if that has to do with because these potentiometers are slightly off in terms of their reading. You know, because when they're both at 0, they're really not both at 0. Even though the software should normalize that. But you can kind of get the idea here. I'm going to turn this back on. So notice the trim wheel. It's kind of going crazy right now. Something happened with the ProSim server. But this is good because then you get an idea of all the different ways it's going. I do have a little bit of a stormy weather scene, so you're probably seeing a lot of that too. So far it works pretty good, minus the fact that it's going crazy right now. And with that, I think that's good. And I'll look at some more videos up of the rest of this once I get this all cleaned up and finalized. Thanks guys for watching. Bye.